a lot of those enzymes will be plugged in there, the brush border enzymes that we'll use to break down particles of food and get them to where we can absorb them. Okay, so let's talk about the stomach first. So the stomach, the anatomy of the stomach, it has the different layers, those mucosa that we talked about before with the digestive tract. So the most internal layer is still that simple columnar epithelial tissue. This one has lots and lots of goblet cells. Remember, those goblet cells are the ones that create mucus and send it out to the surface there. The goblet cells create mucus that is bicarbonate rich in this case. Okay, so it has a very high pH, and so it can kind of counteract the pH of the stomach there a little bit. At least just on the surface, right? It doesn't want to totally change the pH of the stomach, but at least on the surface where those cells are, those cells need to protect themselves a little bit, okay? But even with that protection of that mucus, those cells still turn over every 3 to 6 days because number one, the pH can destroy them, but number two, there's a lot of mechanical compression of the cells in that space too, because the stomach can smash up against itself, smash the food, churn around, and that can damage the cells as well. Okay, there's tons of folds in the stomach called gastric rugae, okay? And this allows for expansion of the stomach, okay? It can go all the way down to 50 milliliters when it's totally empty, okay? But then when we fill it up, it can become 4 liters large, okay? So that's all because it's all folded on the inside, and those folds can stretch out and expand when we eat a big meal. Okay, there's little gastric pits. These are the sites of both exocrine and endocrine secretions. Okay, and there's 3 primary cells in there that we'll talk about. The first one is the parietal cells. These are the ones that secrete the acid, hydrochloric acid. Okay, there's also chief cells. These chief cells secrete an enzyme called pepsinogen, and pepsinogen is important. And that's a non-active form of the enzyme that's going to help us break down protein in the stomach. Okay, so it's important for protein digestion. Okay, and then there's enteroendocrine cells, right? So both of these cells so far are exocrine, right? Because they're releasing things into the GI tract, and that's considered outside of the body. But then the endocrine cells are going the other way. So those are releasing things into the blood instead. Okay, and what those do is they secrete primarily a hormone called gastrin. And gastrin is going to be important for stimulating a lot of the digestive processes, and we'll talk about that here in a sec. And then the pyloric sphincter is the next sphincter we get to. This one is going to be at the kind of the end of the stomach before we get to the small intestine. The duodenum is the first part of the small intestine. So it's kind of the gate between the stomach and the small intestine. Okay, so there's an incredible amount of juice that the stomach produces every day. It's somewhere around 3 liters of juices. Okay, that's a lot, right? And then stomach acid, we saw it dissolve a cheeseburger. It could also dissolve a nail if we leave a nail in there long enough. So it's an incredibly caustic chemical that's inside of us at all times. Okay. All right, so take just a sec here and label this. And then I'm going to have you on your app send in the answer to that question there. Okay, so the people in the class, go ahead and talk to someone next to you. People on Zoom, going to send you to your breakout rooms, and I will open that up here on the app in 1 sec. Endocrine cells, yeah, go ahead and send that in. All right, let's see what you guys said there. Looks like most of you have responded. Yeah, so majority of people are saying D. Okay, yeah, and a few others, but we'll talk about that here. So let's take a look. All right, so first of all, A, those are just those holes. What do we call those? All right, gastric pits. It also says it right there too, right? Yeah, so we've got those, okay. And then B, so this is kind of the more zoomed out view, but if we zoom in on just one of those little sections, we see this, right? And so it's kind of color coded there, but you can kind of see what they're releasing, right? So which types of cells are the ones, those blue ones there are releasing HCl, right? So what type of cell should that be? Yeah, that should be the parietal cell, okay? And then we see those purple cells releasing pepsinogen, right? So what should those be called? Yeah, those are our chief cells. And then we see the green ones. We can't really tell what they're releasing, but by process of elimination, those are going to be enteroendocrine cells. So those are going to be releasing a hormone called gastrin, and those release this way, not into the stomach, but into the blood, right? So that would be the right answer. What was that? That was D. So yeah, D would be the answer there. Okay. E is that pyloric sphincter, right? And then F would be all those folds. So those are the gastric rugae. Okay, any questions about the anatomy of the stomach so far? Okay. All right, so let's talk a little bit about digestion in the stomach, what actually happens as far as digestion goes. First of all, just thinking about smelling or tasting food before it even gets to our stomach, that starts stimulating all those glands, all those cells will start doing their thing, right? We all know this when we're hungry and we walk by the calf, maybe, I don't know if the calf does it for you anymore, but you walk by some other restaurant that smells good, it starts getting your juices flowing, right? You can feel your stomach start rumbling a little bit. That's what it is, right? And so that stimulates these parasympathetic glands to start releasing all the stuff we were just talking about. Okay, the stretch of the stomach also stimulates this. Okay, as well as partially digested proteins that end up in the stomach. Also alcohol. All of those things are just stimulators of these processes. Right. Okay, and so then when gastrin is released, we get the stimulation of those different cells. So that stimulates the chief cells, that releases the pepsinogen, stimulates the parietal cells, that releases that hydrochloric acid. Okay, and we're really trying to keep the pH of the stomach right around 1. Okay, once that pH gets to around 1, that gives some negative feedback to stop the release of hydrochloric acid because that's really where it's trying to stay. Okay, gastrin also stimulates smooth muscle contractions. That's why you can start to feel some things churning throughout your stomach when you smell food or when these processes are happening, right? Because that smooth muscle is contracting, churning food around in there. Okay, so at this point, we're already calling the clump of food chyme, right? So chyme is this mixture of gastric secretions and partially digested food. Okay, and so the little bit of we're going to look at all the different macronutrients when we look at this, so proteins, carbohydrates, and lipids. Okay, and how each of those are digested and absorbed. And so the primary one that gets digested a little bit here in the stomach is protein. Okay, this happens via the low pH that we were just talking about. Okay, we know that proteins start to unfold and fall apart or denature when they're in low pH. So we get some of that. Okay, but we also get that pepsinogen, which becomes activated, it gets turned into pepsin by the low pH. So pepsin is the active form of that. Okay. And what these do is they just break down those long chains of amino acids that make up proteins, break them down into smaller chains of amino acids. They're still chains of amino acids. They're not individual amino acids yet, but just starts breaking them up a little bit. Okay. One thing about caffeine here, some of you know, how many people start out their day with a cup of coffee? Okay. You guys on Zoom? You're in this too. How many people start out their day? Thank you. Okay, I'm not going to ask you to raise your hand on this next part, but many of you also start out your day after your cup of coffee with going number 2, right? It happens, right? And part of the reason for that is because gastrin release is stimulated directly by caffeine, right? So when caffeine hits your stomach, that causes gastrin release, that causes smooth muscle contraction all throughout your digestive tract and starts pushing things through. Right? So, okay. All right, so one pathology in the stomach that we can have is a stomach ulcer, okay? And it used to always be thought that this had to do something more like with the food that we ate, like too spicy a food or acidic food or something like that. But now we know that almost all of them, 95%, are caused by bacteria. Okay, and these little bacteria actually just burrow holes through the mucous membrane of our stomachs, and they can end up creating these large gastric lesions, which can be very painful and dangerous in multiple ways. So most stomach ulcers can be treated with antibiotics. Okay. All right, so a little bit about the function of the stomach here. So the absorption and timing. So which nutrients are absorbed here? Okay, so not many, but this is where alcohol is absorbed. Okay, so alcohol hits your system quickly, and you feel the effects of alcohol quickly. One reason is because of this, because it's the first place in the digestive tract that it hits, it actually gets into your bloodstream very rapidly. Okay. Also, some drugs are absorbed here, like aspirin and ibuprofen. All those NSAIDs are absorbed here. And so this is why if you're supposed to have ibuprofen or any of those drugs not on an empty stomach. Right? If you have it on an empty stomach, it's more likely to cause some damage to your stomach, because this is your stomach is kind of put to the test when you ingest a lot of this to absorb that, and it can kind of overwork your stomach if you have it on an empty stomach and just doesn't get spread out enough if there's no food in there. Okay, so the time course: a liquid meal is out of our stomach in 1 to 2 hours. A solid meal takes about 2 to 3 hours. Okay, so that wasn't necessarily an over exaggeration in that video of them leaving the cheeseburger in there for 3.5 hours. That's somewhat similar to how long parts of that cheeseburger would stay in our own stomachs. Okay. Obviously, those peristaltic contractions are working to move the chyme forward. Okay. Some of this is immediately going to go through that sphincter in the small intestine. And so it kind of works like this. We have all these different layers of the stomach contracting. Remember, the stomach has 3 different layers of muscle instead of just the 2. And it can really smash in on itself in multiple ways like this. And it pretty much gets the food kind of spinning and churning around your stomach. And what it'll do is it'll send it down towards that sphincter. Some of it's allowed to come out, and then that sphincter closes. And then it just kind of slams it against that, which churns it up a bunch more, gets everything to mix with those enzymes and the pH that's there. And then it does it again. It churns it around again, sends it towards the sphincter again, leaves it open for just a second. So some of it can pass through, but then closes it. The rest of it gets kind of churned up. And that's the process. That's why we feel our stomach rumbling after we eat a meal, because it really is stuff rumbling around in there. So, yeah. Any questions on that? All right, so let's transition over to the small intestine. The small intestine has 3, let's see, Emmy's got a question. Does it take longer to digest when you're laying down there? Yeah, it definitely does, Emmy. Yeah, laying down after a meal is always kind of advised against because of that, because it can, because the time it takes to get that food out of your stomach is longer, because you just don't have gravity helping you in that process. So it definitely takes longer. Yeah, good question. So the small intestine has 3 different sections to it: the duodenum, the jejunum, and the ileum. Okay, duodenum is the first part. It's just only 10 inches long, so it's a real short part. The jejunum is 8 feet, and the ileum is 12 feet. Okay, so very long, right? All coiled up inside of us, right? You saw these in the pigs. Okay, and so the anatomy of this is we have these circular folds that are in the mucosa and the submucosa, and they're somewhat deep, up to 1 centimeter deep. And the function of these is to really slow down the movement of food. Okay, so when we think of the folds in the small intestine, it's not like they're going down the way that the food's going; they're going the opposite way. So the food kind of gets caught up in the folds as it's passing. Okay, and so all along the lining of the walls, we have these villi, which are like these finger-like projections, which are what you see on the background of the slides. And then on top of those, there's just millions and millions of these little microvilli. Okay, so tiny little finger-like projections on top of those. Okay, and those are cellular extensions that come out of the columnar epithelial tissue cells. And that's really where all the enzymes are located to make up these brush border enzymes that are going to be doing all of the digestive processes for us. Okay, so this is kind of what that looks like. We got the duodenum there first, short part, jejunum, and the ileum. And obviously it's not all laid out like that. It's just all kind of clumped together like a mess, like you saw. Okay. All right. Yeah, so we can just kind of walk through this one together. So the point I was making about the circular folds right here, you can see that they aren't like tracks set up for the food to go down slowly. They're around this way, right? So the food's actually trying to go this way, right? And so those folds aren't speeding up the process, they're slowing down the process of the chyme moving through. And so those are the circular folds. Okay, we can see the villi sticking up. Okay, right? And there's a bunch of little villi on top of each of those folds, okay? And then we can see there's one villus, right? So this part is zooming in right here. So we can see the different villi sticking up, and there's one. And then if we zoom in on one little spot right here, then we can see the little microvilli. And then there's just millions of those little microvilli on top of each of those cells, right? So here's one of those simple columnar epithelial tissue cells, and the top of it is just all those little microvilli, okay? And all of those little microvilli are what include all of the little enzymes that are plugged into the cell membranes there, okay? Inside of these villi, we can see that there's both capillaries, okay, and lacteals, which are part of the lymphatic system. Okay, so the capillaries are obviously there to absorb the nutrients that are brought in, okay, but primarily the carbohydrates and the proteins. But then the lacteals, the lymphatic system, is how we absorb lipids. We'll talk about that here towards the end. Okay. All right, any questions about that so far? Okay, so let's talk about a few of the associated organs with the digestive system, and then how those are involved in these processes. Okay, so the liver is 4 lobes. You guys saw the livers in the fetal pigs you dissected. Okay, if we get down kind of on a microscopic level, the hepatocytes, which are the liver cells, are arranged into little lobules, which is what these are. Okay, they kind of look like these hexagon-shaped lobules, and they have a central vein inside of each of the lobules. Okay, so the blood flow here is again somewhat unique. We kind of have this is part of that portal system that I talked about before, where the blood, we have 2 different arteries coming in. Oh, thank you. Yeah, thanks, Zita. Yeah, which part absorbs more nutrients? Hannah, were you talking about the small intestines? Yeah. Yeah, so we'll see that in one sec, but the bulk of it is actually done in the duodenum in the first part, but we'll get to some of that. But the duodenum is where most of it happens, right in there in that very first part. Good question. Thanks, Zita. Yeah. Okay, so the blood flow to the liver, we see the hepatic artery comes in, and that's what's going to supply oxygenated blood to the cells of the liver. Okay, but then we have the hepatic portal vein, which is delivering blood. But remember, that is the blood that came from the digestive tract, right? Because we have the capillary beds inside the digestive tract, which are absorbing nutrients. That goes into a vein, which eventually dumps into the portal vein. And then that portal vein dumps into the liver, but it hits another capillary bed there, right? And that's how we deliver nutrients to these cells of the liver, because all these liver cells are very responsible for processing most of our nutrients. Okay, so this is where we had one of those capillary types. So we talked about the fenestrated capillaries that have large holes in them. And so this pretty much allows the hepatocytes to be in direct contact with the blood, to be able to just absorb those nutrients right out of the blood and take them in to process. Okay, both of these different blood supplies empty into the central vein here in the middle, and then all of that dumps into the hepatic vein, and then eventually that'll get back to the general circulation. And this is kind of what that looks like, right? So again, that portal system is a unique way where we have a capillary bed, vein, and then another capillary bed, vein, before we get back to the general circulation. Okay, so we can see that set up. We have the hepatic arteriole delivering oxygenated blood, or the portal venule, which would be bringing that blood from the digestive tract, right? And then we also have a bile duct, which we'll talk about in a second. That's going to be heading out the other direction. Okay, but all of that's going in here to deliver oxygen and nutrients to those liver cells, and then eventually connect back out connect this way and get back into that central vein and empty out of the liver. Okay, so liver has a lot of functions for us as far as digestion goes. It makes and secretes bile into the small intestines, somewhere around 250 to 1,200 mils of bile per day. Okay. It's mostly made up of what's called bile salts, which are made of mostly cholesterol. And the function of this is to help us emulsify fats. And what I mean by emulsify is that it takes like clumps of fat picture like when you put oil in with water, the oil kind of all clumps together, right? Emulsifying means kind of getting in between that and breaking up those larger clumps of fat. Okay, bile pigments are also included in bile. That contains something called bilirubin, which gives bile its yellowish color. This is also the thing that can give your skin a yellowish color, which we'll talk about in Friday's video, and that's called jaundice. Okay. Okay, the liver is very important for making those plasma proteins. We talked about that. It's very important for detoxifying the blood. It has one of the largest smooth endoplasmic reticulums of any tissue, and then very important for storing nutrients. This is where our second largest storage site for glycogen, vitamin A, iron, other things are stored here as well. Okay, so that's the liver. Let's talk about a couple other organs associated with the digestive tract, the gallbladder and the pancreas. You guys have identified all of these already in your dissection. Gallbladder is really just this little sac. It doesn't have any special function to it. It doesn't have any cells that are making anything. It's just a holding place for bile. Okay, and it kind of it serves as a way to build up a bunch of bile and then have that bile be released into the small intestine when it's needed. Okay, and it does that. So stores and concentrates bile, secretes into the duodenum via that common bile duct. And so in some of your pigs, just last week when I was walking around looking at some of you were asking where the gallbladder was. We could find it, and then you could see this little tube that kind of went down from the gallbladder, and that's the bile duct. Okay, the pancreas. We're only going to talk about the exocrine portion of it here. The endocrine portion of it, we'll talk about it at the end. The endocrine portion is what makes insulin and glucagon, those hormones, but the exocrine portion secretes something called pancreatic juice. Okay, so when we talk about type 1 diabetes, we talk about the pancreatic beta cells being damaged in that process. Okay, those are the beta cells, those are the ones that make insulin. The exocrine portion, these are called the Acini cells, so just different cells found in the pancreas. Okay, so this pancreatic juice contains bicarbonate ions of pretty high pH, so this kind of counteracts the pH from the stomach as the chyme enters the small intestine, and then lots and lots of digestive enzymes. Okay, this is where primarily almost all of our digestive enzymes are made, is by the pancreas. Okay, so yeah, so this is just kind of labeling those organs here, so we can kind of do this together. These ones are pretty obvious. So A would be the gallbladder, obviously this little green sac with a bile duct connecting down here. Okay, B is our duodenum. C is going to move into the jejunum, the second part of the small intestine. And then D is obviously the pancreas. And we can see this little tube part of the pancreas that comes down here. And that's where it's going to release those pancreatic juices. Okay, any questions about that anatomy so far? Any of that before we move into the function of all of this? Okay. All right, so let's talk about how digestion is controlled and how all these different organs are involved in that process. Okay, so two primary hormones here that are involved in this, one called secretin. Secretin is going to be released by enteroendocrine cells, so similar to the ones we saw in the stomach, but these are found in the small intestine instead. Okay, and they're stimulated to be released by, as soon as that chyme enters the small intestine, that stimulates release of secretin. Okay, secretin has these kind of three primary actions. First of all, it tells the stomach, all right, your job's done, so you can stop releasing what you were releasing, right? So it inhibits the parietal and the chief cells. Okay, since the food is now in the small intestine, we can kind of slow down what the stomach's doing. Okay, also decreases stomach motility. So same idea, kind of letting the stomach take a break now because the chyme is entering the next stage. Okay, and then it also stimulates bile production as well as pancreatic juice production and release. Okay, so it goes directly to the liver, tells the liver to make more bile. Okay, goes to the pancreas, tells the pancreas to make more pancreatic juice and to release it into the small intestine. Okay, so that's secretin. And then secondly, we have cholecystokinin or CCK. The stimulus is the same as above. So just when chyme enters the small intestine, okay? And the actions are more about the secretion than they are about the production in the previous one, okay? So this causes the gallbladder to contract and squeeze that bile down into the small intestine, okay? Causes the pancreatic enzymes to be secreted. And it also is a satiating hormone, which means it makes you feel like you're full. You're not hungry anymore. Okay. So let's take a second. I'm going to send you back to your breakout rooms. I want you guys in class to kind of discuss this. I want you to kind of take what those hormones are doing on the previous pages and kind of fill in what's happening here step by step. Okay, so we can start out with the chyme entering the duodenum, but then I want you guys to take it from there. Okay, so go ahead. I'll just have you discuss this for a couple minutes, and then we'll come back. Go ahead. All right, so let's come back together now. Everybody should be back from the breakout rooms. So we got this is really the control of digestion, right? So we're starting out with the chyme entering the duodenum. This is going to do what's in number 2 there, which we can see those little enteroendocrine cells there starting to release stuff, right? So that would be number 2. We see the secretin and cholecystokinin or CCK are released because of that stimulus of the chyme entering the duodenum. Okay, then we can see some of those going and interacting with the pancreas, right? So the actions on the pancreas are going to cause the stimulation of pancreatic juice release. Right, so they both had that action, right? Both secretin and CCK had that action, okay? And then we can see some actions happening here with the gallbladder next, right? Or sorry, that was 5. So we're going to the liver next, okay? So secretin stimulates the liver. Oh, you guys can't see that. Shoot, there we go. There we go. You guys on Zoom can see it, but in class you couldn't. All right, sorry about that. Okay, so yeah, number 4 there is secretin is stimulating the liver to produce and release bile. Okay, and then lastly, number 5, that CCK is stimulating the gallbladder to contract, as well as the little sphincters along here in the gallbladder and down here, which allow things to enter into the small intestine. Those will relax and open up. Okay. All right. Any questions about any of that? See, some of you still writing, so I'll give you another sec to finish writing. Okay. All right. So that's really kind of starting us out, getting this whole process going, and then we'll spend the next few minutes here just discussing how each of those 3 macronutrients are digested and then absorbed. Okay, so let's start out with carbohydrates. Okay, so carbohydrates are digested. First of all, we talked about salivary amylase, right? So we're starting to break down carbohydrates chemically all the way up in the mouth, right? Because that was in the saliva. Okay, but then by the time we get down to the small intestine, we have another amylase called pancreatic amylase. Okay, this is released by the pancreas in response to those hormones we were just talking about. This is going to break down our long chains of monosaccharides, also known as polysaccharides, down into disaccharides, right? So we're just going down to the 2 here, okay? And then those disaccharides will interact with brush border enzymes that are found on those cells, on the microvilli, and that's going to break them down into the monosaccharides. And so we got to get them down to monosaccharides before we can absorb these. Okay, so then that's the digestive process, and then these are absorbed through these intestinal cells. okay, into the blood. So it kind of just goes right through the cell, all the way straight through into the blood, okay? But it does it with the help of sodium, okay? So sodium typically has a strong gradient to go into the cell, right? Just like it did with an action potential, right? We had a lot of sodium on outside, not much on the inside. So there's a strong gradient for sodium to go in. There might not always be a strong gradient for glucose and some of these other monosaccharides to go in. So we do it via secondary transport, right? Secondary active transport. We're using the gradient for sodium to kind of pull or almost catapult glucose in with it. Okay, and that's what we're seeing right here. Okay, sodium potassium pumps are important for this too, because we've also got to get the sodium out of the cell, right? If we just let that sodium keep coming in, then it would build up and we wouldn't have the gradient for sodium anymore. So we got to push the sodium out of the cell over here. And so those sodium potassium pumps are important for that process. So this is a really ATP dependent process, right? It takes a lot of energy to absorb things, right? And this is why when we're still absorbing something and we go start running, we get stomach cramps, right? Because we're kind of shifting blood away from the stomach when we do that. And we're now having to rely on glycolytic metabolism to do these processes. That creates some lactic acid that can cause some muscle cramping there in your smooth muscle. Okay, Gatorade takes advantage of this. All types of sports drinks takes advantage of this by mixing salts and sugars together, right? Because when we have salts and sugars together in a drink, that helps us absorb both of those better, right? Helps us get more salt into our bloodstream, as well as helps us getting more sugar into our bloodstream. And nobody would ever just drink salt water, right? So you got to have sugar there just so we'll actually drink it. Okay, so that's the carbohydrate one. Okay, proteins, somewhat similar. We talked about proteins digesting starting up in the stomach with pepsin, as well as with the low pH. But then once we get it down to the small intestine, we have these pancreatic proteases. Okay, so there's kind of three examples here to the right. And we have the inactivated form first, which is trypsinogen, chymotrypsinogen, procarboxypeptidase, and then those are all converted into the active forms, okay? And then those are the things that actually help us break down proteins, okay? So at this point, those proteins are just these long peptide chains, so just a bunch of amino acids strung together. So we're still just breaking those long peptide chains down into smaller peptides by those enzymes there, okay? But once they get small enough, then they can start interacting with those brush border enzymes. And then we're finally going to break those down into individual amino acids. And again, that's the point we got to get to before we can absorb these. Okay. And these are absorbed into the digestive or into those intestinal cells in the exact same way that the monosaccharides were via co-transport with sodium. Okay. So we got the digestion, absorption of carbohydrates, of proteins. Now let's talk about lipids, okay? And this is just kind of showing that same process of breaking down those polypeptide chains into amino acids, co-transport there, and then eventually making it all the way to the bloodstream. Okay, so the lipid process is a little bit more complex. We've got these 8 steps here, but this really starts up in the stomach with gastric lipase. Okay, and this is going to break up lipids, break them up into, just into smaller chunks of lipids. Okay, then we have bile salts we're already talking about that emulsifies those fats, breaks them up into even smaller. Okay, and it really does that by surrounding them to separate them from the other lipids. Okay, and then we have special enzymes from that pancreatic juice called pancreatic lipase, which is going to break them down into even smaller fat droplets. Okay. And then this kind of wraps them around, or they get wrapped around by a structure called micelles. Okay, and these micelles kind of wrap them around, protect the lipids from the water, because when they interact with the water, they tend to clump together. So we want to keep them in the smaller chunks that they are. Okay, so that turns them into micelles. Okay, and then those micelles pretty much go up to the intestinal cell and dump the contents of that fat inside to the intestinal cell. Okay. Inside the intestinal cell, they're surrounded by proteins. Okay, those lipids are now surrounded by proteins, kind of make this ring of protein around them. That's when they become something called chylomicrons. Okay, chylomicrons can show up in the blood. They can be risk markers for cardiovascular disease and some other things. But finally, these chylomicrons get dumped into the lacteals, which is part of that, again, part of the system that shows that we saw those different vessels up in the microvilli, right, in the villi with the capillaries and the lacteals, okay? And eventually that gets dumped into the venous system. And then finally, this will make its way to the liver. And then the liver has a job of converting these chylomicrons into the different cholesterols that we're used to seeing when we get our cholesterol checked. So LDL, which is our bad cholesterol, right? That's our low density lipoprotein. HDL, that's our good cholesterol. And there's a bunch of other ones kind of in between. Okay, so this is just kind of showing that process. We don't really have time to let you fill it in. So, but the steps really match here, right? So steps 1 through 4, 5 through 7 there, and and then a little bit more on step 7 here. But yeah, this is just kind of showing that process. These are those little micelles dumping the lipids in, eventually turn into the chylomicrons, get into our lymphatic system there, make their way to the liver, and then they turn into all these different lipoproteins there. Okay, so yeah, go ahead and fill that in when you have time, but we're out of time here today. But that's the last step here with lipid digestion. All right, guys, so have a great rest of your week. Make sure to watch that video for Friday, do the quiz for Friday, and then we'll see y'all next week.